In a situation where you first build the main roof section, the rectangular portion that you see on your screen, and then build the addition on top of that main roof, it's often referred to as a California roof. The gray triangle on the drawing is the area where the two roofs overlap. This method of framing is practical for adding an addition to an existing structure, or in the case of new construction, it's an alternative method to framing a roof using a traditional valley rafter approach. Start by taking a look at the roof framing plan. This is the main section, the area that's grayed, and that's 6'4". This is the addition, which is 8 feet, and then we're allowing for a 2-foot overhang. The span of the addition is 12'8", and we'll be using common rafters for that section. We'll be using what are called blind valley rafters for the California portion, and those are set at 2 foot on center. Let's take a section through the roof now. All right, focusing on the blind valley ridge. Perhaps the simplest method is to approximate the length of your ridge beam. Set it in place, cut your rafters, set those in place, and then cut the ridge beam to length afterwards. However, if you want to learn to use the math, this is how we do it. And this is the ridge beam in question, ridge beam C. Let's point out point B, and that sits above the plate line, 7 inches, which is the height above plate line. Point A, the distance between those 2 points is 6'4". Between A and D, this is the rise, which is 3'2". Let's take a closer look at the detail. Now, there's several components to this. We're going to break it down here. This is point D, we talked about earlier. The area highlighted in green is the loss at top, and we talked about that on the last exercise. That's 3/8 of an inch. The area in red is the hypotenuse of the sheathing thickness. Add those two together and you get the shortening rise. All right, we're going to break this down. This is the ridge shortening. Step 1, you need to enter the loss at the top. And we've done that calculation before. Let's take another look at that. And this is just a recap. We determined it was 3/8 of an inch. Step 2, we need to add basically the hypotenuse of the sheathing thickness. And here's the formula for finding that. We know that the thickness of the sheathing is 1/2 inch. So to determine the hypotenuse, you just need to punch in this formula. It's basically the thickness of the sheathing times the unit rise, you square that, plus thickness of the sheathing, square that. Or you can just take your tape measure and measure that in the field. It's probably a lot simpler way to do that. Now we add step 1 to step 2, and we come up with the result of 15/16. For step 3, we have to calculate the run. This is the shortening. So this is the rise divided by the unit rise. Go through the math, and the shortening result is 1 7/8 of an inch. And we'll just plug that figure in right here. So this is the shortening run. Now we know what the mathematical height of the ridge is. That'll be 3'2" from point A, or 3'9" above plate line. To determine the actual height of the ridge, we have to work in the loss at the top, so you drop that 3/8 of an inch, and the result will be 3'8" and 5/8 of an inch. All right, let's take a 3D view look here, break it down into its components. Before you frame the California Valley, you need to put down the roof sheathing. And you see we've cut away part of the roof sheathing here. This is the ridge beam that we just spoke about. We're using blind valley jacks, and those sit on top of a valley strip, usually a 1x. Common rafters, lookout rafters, and barge rafters we've already spoken about. And this is the addition. Let's take a closer look at some of the calculations here. I've color-coded these different planes to help you visualize. So between point A and point B, we already mentioned that the total run was 6'4". Looking at it in plan, that's where that occurs. So this is on the horizontal plane. The rise between A and D, we said the total rise was 3'2". That's the elevation between A and B. We said was 6'4". Between A and D, we said was 3'2". Between B and D, that's the mathematical run. And all that is the total run times the unit length, and the result is the mathematical length of 7'1". Between C and D, this is the mathematical run of the hip, and here's the formula for that. 6'4" times the unit length of 18 gives you the mathematical length of 9'6". B to C, that just tells you the length of the side, which is 6'4". That's the same as the total run. And there it is in plan. There it is in 3D view. B to D, that's a useful calculation. And we said that was 7'1". C to D, 9'6". These measurements are useful for snapping your chalk lines. Okay, point E, this is your shortening point. We talked about that a little earlier, and we said the shortening distance was 1 7/8 of an inch. But to get your mathematical shortening, well, you need to multiply that by your unit length of 13.42. And that gives you a mathematical shortening length of 2 1/8 of an inch. All right, next we need to chalk the offset. This can be done in a different color chalk. For your valley strip, if you use 1x stock, that'll be 3/4 of an inch thick. Your offset will be 1.5 inches. The formula is B divided by your unit rise, so 0.75 times 0.5 will give you a result of 1.5 inches. Let's take a closer look at your Raptor layout. This is the plan view. And the total run we already said was 6'4". Here's your framing point A. The distance between A and C is your total run of 6'4". And this will be Raptor 1A. So that's easy to figure. Just take 6'4", multiply by your unit length, and you get the mathematical Raptor length of 7 foot. Now since these are 2 foot on center, we know that 1B will be 2 feet shorter, and 1C will be 2 foot shorter than that. So we start off with 6'4", you subtract 2 feet, and you get 4'4". Multiply that by your unit length, and the mathematical Raptor length is as shown. 1C will be 2'4" times unit length, and so forth. You can also work this formula out and just subtract 2 feet 2 7/8 from your previous Raptor. All right, let's take a look at the Raptor layout now. This is the Blind Valley Raptor layout. All right, point A is your framing point at the ridge. Point C will be your seat cut. And we're looking for the mathematical Raptor length. So there's a couple of these. One is 1A. Mathematical Raptor length is 7 feet. 1B will be 4'10" and 1/8", and so forth. Your ridge setback is half the ridge thickness. We've looked at that before. And D is your valley strip shortening. And we also need to set your saw angle when you're cutting that at 45 degrees. And this is determined by the thickness of the valley strip. In the case of a 1x, that'll be 3/4 of an inch. And we'll take a closer look at that. In this close-up 3D view, the dashed line that you see is D, your valley strip shortening line. Your saw cut angle will be 45 degrees. And we'll sit back and take a look at the 3D view and just examine it at your leisure. And that's basically it for your California framing.